Alright, today's lesson for Algebra 1 is lesson number 89. We're going to be talking about comparing data sets. So we've talked about different ways to represent data, right, with histograms and box plots and dot plots. Now we're going to look at maybe two sets of data that kind of relate. So maybe sales for two different companies, or could be two different years. Some sort of data that was gathered in one year compared to the same kind of data that was gathered in the next year. Okay, so we're going to look at ways to do that. Here are some things that we may want to consider. First of all, we probably want to look at the measures of center, so the mean or average and the median. Okay, the mean is going to tell us, is the average of one set lower or higher than another? And the median will tell us how we can split the data in half. So is the lower half of the first set of data close to where the lower half is of the other set of data, and so on. Okay. We can also use the mean and the median to talk about if our data is symmetric or skewed. Maybe they're both kind of skewed to the left, but one's more symmetric or one's more skewed. So we could talk about those things as well. We also want to talk about the measures of spread. So that's going to be how spread out is the data. Okay, what's the range, okay, from the minimum up to the maximum? Does one set of data have a wider spread, or does it have a bigger range? So is the data more spread out? Or maybe if the range is smaller, then we would say that data set is more consistent. And same with the IQR. The IQR, remember, tells us the interquartile range, so it accounts for the the middle 50% of the data. So we could look at the middle 50% of the data in each case and compare the data that way. Here's an example. So this shows they basically went out and did a survey, and they found the average age for 15 different NFL teams and 15 different MLB teams. Okay, so football and baseball here. So first they found the average on each of those teams, and then they looked at those 15 numbers and found this information. So the mean for the NFL was 25.98, and so on. Okay, we can look at this, and if we want to look at the measures of center, so the mean and the median, I can see that they're both lower for the NFL than they are for MLB. So we would say that the mean and median ages are lower for the NFL, which means, okay, so why, this is what we want to get to, is what does that tell you? What can you say based on that? So that means that on average, NFL players would be younger than MLB players. Okay, and that's just on average. There's always going to be NFL player, if you can always find one that will be older than a certain MLB player, but this is just saying on average the ages are the NFL players are younger. Okay, the IQR and the range, so these are different measures of spread. I see that for both of them it's higher. The higher number is for the MLB players' ages, so that tells us that the average age on teams is more varied here. Okay, so the age for MLB players, for each team, it's more varied, so, or from team to team, I should say. So within the 15 teams that they looked at, the average age there was more varied than it was for the NFL. Okay, and then we could also word this kind of the flip, or the reverse would be saying that the range and IQR are lower for the NFL, which means that those ages, the ages of players on those teams was more consistent. The average age for those teams was more consistent. Okay, here's another example. This shows the age of 10 contestants on 2 different game shows. I would start by reordering these lists from least to greatest. I'll just show that really quickly here. If you want to practice, just go back and make sure that your set matches mine. Okay, so reordering these from least to greatest, I can then find the range by subtracting the highest number and the lowest number. So for game show 1, I get 30, and for game show 2, if I do 41 minus 21, I get 20. Okay, now I'm going to find the median. I just work my way into the middle here. I find that Q2 would be 32.5 then, because I'm taking the mean of the 2 middle entries. Okay, then I go to the middle on each half. So I have 25 here and 41. Okay, and I can subtract to find the inner quartile range here. So 41 minus 25 is 16. And then the median was given, remember I found that first, so that's the same as Q2, it's just 32.5. I can do the same thing for game show 2. I cancel out, find the median, that's 33, then I cancel out on each side to find the quartiles, and I get 33 as the median and then 12 as the inner quartile range. The average, I just add these up and divide by 10 because there's 10 contestants there, so when I do that, I get 32.9 as my mean for show 1. And for show 2, I get a mean of 32. Okay, so then below are some things I can talk about for this data set. So I noticed that the mean is lower for the second show. So I could write that. That means, okay, remember that's what is important here is to talk about the implications of these things. So what can I say, seeing that the mean is lower? Well, that means that contestants on average were younger on the second show. Okay, so if I just look at the average age, it was lower for the second show. However, the median is lower for the first show. So even though the average of the ages on the second show, the contestants are on average younger, since the median is lower for the first show, that tells us that there are more young contestants on the first game show. Okay, and basically that is because the median is, the median is lower. Sorry, the median is lower for the first show, so that means the first half of the data for show 1 is all below 32.5. For show 2, the first half is below 33, so that means they have, since the median is lower for show 1, they fit more in that younger, on the younger side. Okay, so the IQR and range, so I see that for both of those, the IQR and range are smaller for show 2. That means that the ages are more consistent on this show, okay? So it's less spread apart. I could say kind of the reverse of this and word it, I would say the IQR and range are larger for show 1, which means the ages are more spread apart. And we can see that kind of clearly with the actual data too, right? So it goes from 18 to 48 for show 1, so that's pretty spread out. And then for show 2, it's just between 21 and 41, so not as dramatically spread apart. Okay, the next example here is showing 2 different grocery stores and the number of days that they sold specific numbers of turkeys. Okay, so these are in the 2 weeks leading up to Thanksgiving, so there's 14 days. So the grocer A sold 10 turkeys on 2 days, and then grocer B sold 10 turkeys on 5 different days. Okay, so these are the number of days, and these are the number of turkeys they sold. Okay, so I want to start by making a dot plot for each of these. I'll label my axes. You want to make sure when you're comparing data and you're the one that's creating the graph, you want to make sure that they are scaled the same way. Just because visually that's how it makes more sense to be able to compare it that way. A lot of times companies will kind of purposely give different scales so that it looks like maybe their product does better than another company's product, but really it's just that they're using a different scale, so the bars might look bigger, but it's just the way that the numbers are spread out. So you really want to be consistent between your two different, between the data that you're comparing. Anyways, though, for this dot, for the dot plot here, for 10 turkeys we had 2 days, so I put 2 X's for grocer A. There were 5 days that they sold 20, 5 days they sold 30, and 2 days they sold 40. For grocer B, we had 5 days at 10, 5 days they sold 20, 1 they sold 30, and 3 they sold 40. Okay, so one of the things I could look at is what type of distribution is this? I see that A is symmetric and B is more right skewed. Okay, so that tells me things though. Okay, it's not enough. This doesn't just say identify the type. It says to compare the data. So really what we should do is talk about what this means. Okay, so A is symmetric. Okay, that means when I cut it down the middle, I have a mirror image. Okay, the mean and the median are both equal to 25. So that means the grocery store A sold less than average. Okay, so this purple line would be the average. So they sold less than average on half of the days and more than average on half of the days. Okay, over here though, for company B, their graph kind of looks like this. So it's more right skewed. Oh, sorry. It's more right skewed. So that means, remember from our definitions, that also tells us that the mean is greater than the median. Okay, so the mean is over to the right. So the mean is going to be somewhere in here. Okay, but the median, if we kind of cross these off, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1, 2, and then I have 2 in the middle. But they're both 20. So really my median here, let's undo some of these. My median here is 20. Okay, it's in here. But the mean is 21. So that means my average is higher. So I could say on more than half of the days, they sold less than average. And then on less than half of the days, they sold more than average. Okay, so typically their sales are really between 10 and 20, but there was just a few days that pushed that average up. They may want to consider this, for example, if they're going to buy, they're thinking of how many turkeys they should have available for people to buy, right? They know that even though they sold 40 on a few days, and even though their average looks like 21 point something, their kind of typical sales are really more in here in the 10 to 20 range. So those are all things that they would want to consider. Okay, so this would be, we could say more days. There were more days that they sold less than average, and for the symmetric, there was an equal number of days above average and below average. Okay. Alright, so this would be an example of using a dot plot to compare. The range of these is talking about the same amount, right? There's either 10, 20, 30, or 40, so there's kind of the same range between them, and the IQR we could figure out, but it's not really presented in a way that we could do that easily, so we may not want to use that as a comparison here. Okay, and then the mean and the median we could kind of approximate using this, or we could find it actually using these dot plots and then compare those as well. Over here, this next example is talking about the gross earnings for the top 10 movies in 2012 and 2013. So 623 would be number 1, and then this would be number 10. Okay, so we already have them in order. It's kind of like max to min going down, but if we read it going up, it's already from least to greatest. Okay, so we can see the min and max values. I could also find the median and the quartiles. This problem, is wanting you to use dot plots box plots. Okay, remember the box and whisker plots? So we're going to create those in order to compare the data here. Okay, so I can cancel these out. I see that the median is going to be between, I have two middle entries, right, 303 and 292. So when I take the average there, I have 297.5. Canceling these out, I get Q1 is 408. Q3 because it's the upper one, right? And then Q1 is 237. The min is 216 and the max is 623. Okay, and I can do the same thing with 2013. In fact, since they're in a nice line like this, I can already tell, I also drew the box plot. I can already tell that these two here will be the middle two entries. This will be Q3 and this would be Q1. Okay, so if I average out 291 and 268, I get 279.5, and then these are my Q1 and Q3, the min and the max. Okay, then I can plot this one. Okay, so in comparing these box plots, there's a couple things I could say. I can notice they're both right skewed, right? So this example here, the bottom one kind of goes like this. So it has a long kind of tail to the right. This is 2012 and 2013. So the 2013 one is also right skewed. The median is here, and there's more happening to the right, so it's not symmetric. There's kind of a tail on the right, so it's right skewed. But we may say that the 2012 data is more symmetrical. It's because, the 2012 data is more skewed because it has a wider range that it covers. So the average is probably going to be more dramatically above the median. Okay, the medians here are both sort of close to each other, but so the average would be maybe somewhere in here for 2013, but for 2012 it'd probably be closer over here. It'd be more shifted because of the larger numbers that are there in that set. I could also see that the data looks somewhat similar if I look at the table, but really these last two for 2012 really just push the data over the top. Otherwise, it actually does look pretty similar. There's even lower values, so the number 10 movie in 2012 actually earned less than the number 10 movie in 2013, but the top two movies both earned more in 2012 than the top two in 2013. So that just kind of shifts the data. So lots that we could talk about here. Just for closing, we talked about what we discussed today, how we could do that. So we discussed comparing data. We can do that using the mean, median, range, and a quartile range. We could use symmetric versus skew. This relates to the other things that we've been learning because it deals with the graphs that we've learned how to create and some of the terms that we've learned. In real life, this would actually come up a lot. A lot of the times companies do some sort of a data analysis. They want to compare each 1 month to the next, their productivity or their sales. So comparing data is really important. If they are choosing a new product, they also would be comparing data then. They want to learn about all the different statistics they can find for the maybe there's two competing products that they want to invest in. So they want to compare the data and be able to figure out what would be the better investment. Okay, so go ahead and start on the homework for this lesson. Give it your best shot, and I will see you tomorrow. Thank you.